Good morning, all of you. Today we are starting the second chapter of chemistry, that is acids, bases, and salts. There are so many chemicals. The two main sources of most of the chemical substances are one, that is animals and plants. This is one source. Another source for getting chemical substances, second one, minerals and rocks. First one is animals and plants. Second one is minerals and rocks. The chemical substances obtained from animals and plants are called organic substances. The chemical substances obtained from minerals and rocks are called inorganic substances. Earlier, inorganic compounds are classified as acids, bases, and salts. Inorganic compounds were classified as, earlier it was classified as acids, bases, and salts. Acids means the substances which are having sour taste, S-O-U-R, sour taste. It is coming from the Latin word meaning acidus. Acidus. Acidus means sour. S-O-U-R, sour. We have so many acids we are dealing with in our daily life. Lemon juice, it is acidic. Vinegar is acidic. Then tamarind, which has tartaric acid, acidic. Then tomato, that is, tomato contains oxalic acid. So we are dealing with many acids, that is sour taste. We deal with bases also. Bases are having bitter taste. Bases are having bitter taste. It is soapy in nature. Examples in our daily life, that is washing soda, basic. Baking soda, basic. Now coming to salts. Salts are made from acids and bases. Acids are mixed with bases. We get salts. There are different types of salts. The salts which are having the taste of common salt, we call them as salty. Salts which are having the taste of common salt, we say they are salty. Now, salts, we know salts are soluble in water. Examples of salts are common salt, that is sodium chloride, copper sulfate, then silver nitrate. So many salts are there, calcium carbonate. So we have acids, bases, and salts. We'll be learning acids, bases, and salt in this chapter. How can you test an acid? By tasting? No. Don't taste any chemical. It may be dangerous. It may be poisonous. So it is dangerous to taste any chemical substance. So never taste any chemical to find whether it is sour in taste, to find whether it is bitter in taste. Do not, this is not a method. Tasting is not a method to check whether a substance is acidic, basic, or neutral. Now let's come to the test of how to test an acid. How to test an acid. You are supplied with a compound, and the question is test whether it is an acid or base. So for that we are going to the testing part of acids and bases. See, collect the following solutions from the science laboratory. Hydrochloric acid, the word itself has acid. Sulfuric acid, H2SO4, nitric acid, acetic acid. So this is acid, 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 acid. Now you see sodium hydroxide, this OH. When there is OH, that is base. But when you are supplied with a substance, you cannot say it contains whether it contains OH or not. Then calcium hydroxide, it also has OH. Potassium hydroxide, OH. So these things are bases. Magnesium hydroxide, see, OH. Ammonium hydroxide, OH. In acids, you see H, 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 here this H, and rest bases. But you are supplied with a substance, you don't know whether it contains H or OH. So, what you have to do to test? So, you can use some substances called indicators. Indicators, maybe red litmus solution, blue litmus solution, phenolphthalein solution, methyl orange solution. These are the indicators with which you can test whether the given substance is an acid or base. Suppose you are given a substance in a test tube. You have to check whether it is acid or base. So you make a solution with water. That substance, to that substance you add little bit of water, and to that you add red litmus solution. If it is acid, you will find no change. Or instead of this adding red litmus solution, if you are adding blue litmus solution, then that blue color changes to red. So acids change blue litmus to red. Acids change blue litmus to red. If you instead of adding this blue litmus solution, if you are adding phenolphthalein solution, phenolphthalein is actually a colorless solution. If you add that phenolphthalein to acid, it is colorless only. Colorless only. If you are adding methyl orange to acid, then you will get an orange red color. Orange red color, a mixture of this orange red. If it is a base, suppose the substance contains base, bases change red litmus blue. It change this bases change red litmus solution blue. Means if you are adding a red litmus solution to a base, this base will change that color to blue. But if you are adding blue litmus solution, no change. No change. If you are adding phenolphthalein to basic solution, then it will be pink. If you are adding phenolphthalein, it is an indicator, 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 indicator. So if you are adding this indicator phenolphthalein to base, you will get a pink color. If you are adding methyl orange solution to a base, you will be getting golden yellow color. So put a drop of each of the above solutions on a watch glass one by one and test with a drop of the indicator shown on table 2.1. What change in the color did you observe when red litmus, blue litmus, phenolphthalein and methyl orange solutions for each of the solutions taken? So tabulate your observations in table 2.1. These things are there in the laboratory, but now I am unable to show you these things. Red litmus solution is there, blue litmus solution is there in our laboratory, phenolphthalein is there, methyl orange is there. You'll be getting a better idea if you see, means if you get the first hand experience. But here, we are unable to show you these things. So, for the time being, you learn these things. Once the school reopens, uh, you can see all those things. So, in acid, if you are putting red litmus, no change. Acid turns blue litmus to red. Bases change red litmus to blue. Bases change red litmus to blue. In acid, phenolphthalein is colorless. In base, phenolphthalein is pink. In acid, methyl orange is orange red, or you can say orange also. In base, methyl orange has got golden yellow color. Now, there are some other indicators. We call them as olfactory indicators, means based on the smell. Based on the smell, you can use onion, you can use clove oil, or you can use vanilla. There is a typical smell for onion, pyaj. Typical smell for onion, typical smell for vanilla, typical smell for cloves, long, clove oil. In the case of an acid, these things retain their smell. Means, in presence, if you are putting in acid, these will be having the same smell. They will retain. Onion will be having in presence of acid. Onion will be having its smell. Vanilla will be having its smell. Clove oil will be having its smell. But if you are putting this with a base, then you will not get the smell. Onion will lose its smell. Vanilla will be losing its smell. Cloves will also be losing its smell. Let's see that. Olfactory indicators. Bases, acids, smell of vanilla. In bases, no smell. Here there is vanilla smell. There is a typical smell for vanilla, we know it. Next, onion. In bases, no smell. In acid, onion smell. Clove oil. In bases, no smell. In acid, there is clove oil smell. So for this thing, what you have to do, take some finely chopped, we are taking this onion, this is easy. This is easy to get. So we are taking onion and take some finely chopped onions in a plastic bag along with some strips of clean cloth. Tie up the bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take two of these cloth strips and check their odor. Odor means smell. Odor. Odor means smell. Keep them on a clean surface and put a few drops of dilute HCl solution on one strip and a few drops of dilute NaOH on one strip you are putting. See, on one strip you are putting dilute HCl, and on the other strip you are putting dilute NaOH. Now rinse both cloth strips with water, means acids and bases show their properties in presence of water. In the moist case, in the moist or in presence of water. We say in aqueous solution. Presence of water means we can say aqueous solution. So rinse both these cloth strips with water and again check their odor. We will see that in presence of acids they will be retaining their smell, but in the presence of bases they lose their smell. That onion smell will be lost. Similar is the case with vanilla and with clove oil. So by checking the odor, you can say whether it is an acid or base. So these are also indicators. We call them as olfactory indicators. Now one question we will be doing. You have been provided with three test tubes. You have been provided with three test tubes. One of them contains distilled water. One of them contains distilled water. And the other two contain and the other two contain an acidic solution an acidic solution and a basic solution. And a basic solution. If you are given only a red litmus paper, if you are given only red litmus paper, how will you identify how will you identify the contents of each of the test tube? the contents of each of the test tube. Say you are given three test tubes. We don't know which one is having distilled water. See, one is having distilled water and other two, one acidic solution and the other one is having basic solution. We don't know. But we have red litmus paper. We have this red we have this red litmus paper. This red litmus paper you have to dip in number 1, number 2, number 3. You dip in number 1. Suppose you find no change. You find no change. If you're finding a change, that is, if the red litmus changes to blue, if the red litmus changes to blue, then this number 1 test tube, there are two possibilities, either no change or a red litmus changes to blue. If the red litmus changes to blue, then we say number 1 is a base. If it is not changing, then it can be acid or distilled water. Acid or distilled water. If it changes, it is a base. Suppose it didn't change. So we have two possibilities, acid or distilled water. And we put the red litmus in the second one. We put this red litmus in the second one. Suppose it didn't change. It didn't change. In the first case, you consider it didn't change. If it changes, it will be base. It didn't change means two possibilities, distilled water or acid. In the second one, again we say it didn't change. Suppose it didn't change. Suppose if in this it is not changing, in this it is not changing, then sure in this it will change. That means this one will be base. This one will be base. Or if you first put in this one, then of course it will be changing. So you dip this red litmus in three of them. The one which changes, that will be base. So the one in which this red litmus changes, that will be base. So suppose the third one got changed. We dipped in this, no change. We dipped in this, no change. We dipped in this, it changed. Red changed to blue. So the red changed to blue. Suppose in this it changed to blue. That means this is the base. Now we have blue litmus paper in hand. Now we have blue litmus paper in hand. And you dip in the first and second. Blue litmus if it changes, then that will be acidic. Acid changes blue litmus to red. Suppose that blue litmus you dipped in this, no change. You dipped in this, it got changed. So blue litmus we dipped. See, when we put the blue litmus in this, what happened? It changed to red. It changed to red. The dip portion got changed to red. That means that test tube contains what? Acid. So the last test tube is containing means this one. In this, no change. So this is distilled water. This is distilled water. So what all things we have seen? We have only red litmus paper. We have only a red litmus paper. That red litmus paper we put in all the three, and in one test tube it got changed. So I put red litmus paper. I put a red litmus paper in this. Where is the change? Suppose in that it got changed means red litmus, the dip portion, it got changed. Dip portion got changed. That means the test tube 3, suppose in test tube 3 it got changed. We have only this red litmus paper. We have only this red litmus paper. Red litmus paper we put in all the three. In one test tube it got changed means that is base. That is base. So do one thing, you fully dip into this. You just push it down. Just push it down so that this entire thing will get changed into blue. You just push it down. So we have what? We have blue litmus paper in hand. Now that blue litmus paper you are dipping in the other two test tubes. If the test tube which contains acid will change that blue litmus to red. So you can pick up which is acid, and the other one in which there is no change either for red litmus paper or for blue litmus paper, that is the distilled water. In this way, you can find out whether it is acid, base, or neutral. Distilled water is neutral. So acid changes blue litmus to red. Acid changes blue litmus to red. This we have seen. Blue litmus paper you put the portion where it is in contact. This is dilute solution. Acid shows its property in presence of water, means dilute solution, we say dilute HCl. Dilute HC, acidic solution. It's not purely acid, it is acidic solution, means in presence of water. We can say an aqueous solution of acid. Similarly, basic solution. So acid turns blue litmus to red, base turns red litmus to blue. Distilled water, that is neutral, that will not change any. So that is how we can find out whether we can test the presence of an acid or a base. Next, we'll see how do acids and bases react with metals. Metal plus acid. metal plus acid and metal plus base. First we learn how do acids react with metal. Metal plus acid gives salt and hydrogen. Metal, for example, zinc metal. Zinc metal. Zinc metal you can take as the bottom plate of a cell. Cell, many cells you must have ever ready, like this cell. We buy this cell, 1.5 volt is written here. There is a plate down. There is a plate here. There is a silvery color plate down. That is zinc. You take that, open a spoiled battery and take that zinc plate. That is a metal. Zinc plus an acid, for example, dilute sulfuric acid. Dilute sulfuric acid. Zinc plus dilute sulfuric acid. What happens? This zinc replaces this hydrogen. Zinc replaces this hydrogen. So we'll be getting zinc sulfate and H2. So acid on reacts with metal. This is metal and acid. You will be getting salt and hydrogen. Salt and hydrogen. Means hydrogen gas will be produced. You can check the presence of hydrogen gas by bringing a lighted candle near the gas. It will burn with a pop sound. Burning of hydrogen gas with a pop sound. All those things, that experiment and all, we'll be seeing in the next class. Thank you.